Good evening, students. Very warm welcome for another amazing class on crystal field theory. I have discussed with you Werner's coordination theory. After that came the Wallace bond theory, students. Why the Wallace bond theory was given in order to explain certain magnetic and directional characteristics of the ligands attached to the metal ion, students. And there were limitations of the valence bond theory,
Yes, sir.
lot of assumptions you can see, and also it gives no idea about the color and also nothing about the strong or weak ligands. And in order to go further one step, what we came forward is a crystal field theory. Can you tell me, students, in 1 minute, what is the difference between valence bond theory and crystal field theory? Question, we begin our lecture with a question, student. Question is, what is the difference between VBT, valence bond theory, and crystal field theory, students? You have maximum 1 minute to answer the question, students.
Sir, the major difference between VBT and CFT is that in VBT we explain the mixing of orbitals, whereas in CFT we explain the splitting up of orbitals. CFT is a purely electrostatic model in which ligands are anions and metal ion is the cation.
All right, students, that was okay. There is no need to talk more. The only thing we told you that the valence bond theory involves hybridization of the orbitals of the sp-d orbitals of the metal ion, and the ligands donated their lone pair of electrons into the vacant hybrid orbitals. On the other hand, student, in crystal field theory, we said that the ligands are point charges, students, and that model is purely electrostatic only. There is no covalent or any bond formation here. There is a field, student, and as you have seen, when the ligands are approaching, the central metal ion, what happens, student? What happened? There is a crystal field splitting. Now the next question to you, student: what is crystal field splitting? Question has been asked repeatedly in the exams. Crystal field splitting, student. What is crystal field splitting? Question number 2 on the screen. You have 30 seconds, students. What is crystal field splitting?
Crystal field splitting was when the ligand approach the metal atom, and if it is octahedral, then 5d orbitals is split up due to the fact that dx square minus y square and dz square experience more repulsion and their energy is raised, whereas dxy, yz and dxz do not interact. So this is known as crystal field splitting.
Okay, students, I thank you. I hope warm up session goes on all the time. You know that before the players start their match, they do some warm up exercises. Do they do that?
Yes, sir.
Anytime you go to any class, students, the instructor says, okay, let us have some warm up exercises. Why do we do warm up exercises? If you are a runner, you are an athlete, student. Hey, if you are running 800 meters, you run, you see international level, you will see them. There are warm up exercises continually done. This is the main thing, is to create student energy in you. Energy levels should be high when we take a class. When we are attending a class, our energy should be good, and that is what I try to do, students. I hope you understand me why I do all these brain exercises. They are a part of our teaching, students, and you see that there are so many other techniques which we are using. That one also I will explain to my students how they can improve their memory part, brain part, and how they can improve their overall fitness. Student is very essential for giving a fit paper. I am telling you that we have to keep ourselves mentally, physically, spiritually, emotionally fit for exams. Therefore, my lessons are not only for chemistry, they are for physics, they are for bio, they are basically for life coaching to all the students. Students, we must do a lot of exercises, warm up exercises of the subject which we do. It helps us. Does it help you or not? Question is that to me. Tell me.
Yes, sir.
Okay, that's why I do it. So, students, what you said that now the story is like this, that there are 5d orbital students which has got electrons in the central metal ion. Yes or no?
Yes, sir.
They are degenerate. They have a field, student, field. The field is symmetric. But when in coordination compounds, the ligands are having, you are saying octahedral, tetrahedral, square planar type of geometries. So when the ligands will approach and form, trying to form an octahedral complex, what will happen, student? They are coming from x-axis, y-axis, z-axis, and the result of this is first when the field is symmetric and the ligands are approaching, student, there is a level increase in the energy of the d orbitals. So energy of the d orbital rising, student, as you can see. After that, once they take up, they are approaching from, supposing in the octahedral geometry, they are approaching from x, y, and z axis. Students, what happens? Those three set of orbitals uh, uh, will experience a less interaction as compared to the two which are oriented towards the xy square and dz square direction. So the result of that is a splitting of the d orbital. That splitting of the d orbital is called crystal field splitting, student. So the question number 3 on the screen is thus delta zero we defined as a crystal field splitting energy for
Yes, sir.
octahedral complex. Yes or no?
Yes, sir.
The magnitude of this depends on what, student? Next question. The magnitude of splitting. Lot of questions are already answered by us for the exam, student, when we are doing these question answer sessions. And we do that delta zero, delta O octahedral splitting energy, delta O zero I represented, or I represented by dq10 dq10 dq deci q. So the delta O0 octahedral magnitude of splitting, it depends on student what factors. What it depends on? It depends on the but it depends on the splitting depends on, is it same for all the ligands or is it is different for different ligands? That is our point, student.
So different for different
So
ligands.
it depends on the field strength
Strong field strength of the ligands.
of the ligand, students. Okay, and we defined two types of ligands. One we said which have a high field, and other we said there are
Strong field
ligands which
ligands
have a
and weak
field,
field ligands.
low field strength. So we
Yes.
defined high field, but we defined, student, high field and
Low field.
low field ligands. Low field ligand. This actually we decided after doing we have spectrochemical evidence for these students. Experimentally, spectroscopically, we have studied which ligands are giving high field, which ligands are giving low field, student. And therefore, students, if the field of the ligand is high, the splitting energy
Maybe
will be
more.
more or less.
More.
More. So high field mean delta O large, and low field mean delta O
Oh, less.
less, small. Okay.
Yes, sir.
Okay. Now question number 4 on the screen. What is spectrochemical series, student? All the questions I have taken from previous papers. What is spectrochemical series, students? What is spectrochemical series?
Sir, spectrochemical series is a series of ligands, yeah, list of ligands, which are arranged on the basis of increasing field strength.
Okay, so we can arrange the ligands on the in the order of increasing field strength. ठीक है, students? that is experimentally after spectrochemical evidence is there is a series which has been obtained, student. And as you will see that C N wale C and C, those who are starting with C or those which are with nitrogen, they are more having stronger field as compared to the halogens. Halogens are on the lower side of the field, students.
Yes, sir.
So certain type of tricks helps us in remembering these in the examination. You know that CO is a very strong ligand and it will cause large splitting. Question number 5 is coming, student. What is pairing energy, student? What is pairing energy? Okay, students. If we answer the question, we will be able to do all the questions in this chapter. What is the pairing energy? I talked about the pairing energy, students, in the splitting of the d orbitals. Splitting of the d orbital, we said there is a pairing energy involved, student. What is the pairing energy? You have 30 seconds. That's all.
Sir, pairing energy is the energy required for pairing up of the electrons.
Okay. Correct answer given by Shivangi. Thank you very much for giving me the correct answer. So, if you can answer that question, student, now we are coming to that. You are saying the splitting takes place in two orbitals. T2G is the in octahedral complexes. In octahedral complexes, T2G has a lower energy and EG has a higher energy. Correct? Triplet
Yes, sir.
and doublet. You have two set of orbitals, triplet and
Triplet and
doublet,
doublet.
students.
Yes, sir.
So, case 1, students, if delta O is much larger than P, then what will happen, students? What will be happening if I have a D4 case supposing in D4? If I have a D4 count is D4 for a metal ion, student. If delta O is greater than P, then what will be the preferred, what will be the configuration of the students?
Sir, in this case, pairing will take place and the configuration will be configuration will become T2G4,
Okay, thank
EG0.
you very much. That's absolutely right answer. So you are saying T2G4 pairing takes place when the pairing takes place because delta O octahedral splitting energy is large. That means the ligand is a strong ligand,
Strong
students.
ligand. Yes, sir. Strong ligand.
Strong field ligand will do that. So the delta O is larger than P. The pairing energy is uh, less than the delta O0. So what will happen? The pairing energy is less. The expenditure is there for every pairing. That is what we are saying pairing energy. If electron is single, it wants to, we are going to pair it up. There will be expense, student energy will be required to do that. But that energy is much less as compared to energy required to move the electron from T2G to EG orbital. So will it be a high spin complex or a low spin complex, student? Fast.
A high spin complex.
This will be a high spin complex. You are saying pairing has taken place. Then how it will be high spin complex? What do you mean by spin?
Okay.
More unpaired electrons means more high spin. Less unpaired electron means low spin. So if the pairing takes place, it will be low spin or high spin complex, students.
Low spin.
Low spin complex, that is the correct answer, students. So it will be a low spin complex. Pay attention to each and every word I'm talking to you, students. You should be very concentrated, focus. Our brain exercise is very essential. You are answering the questions, they will become the questions in the papers, and therefore we will be able to solve 100 of the 100 questions, students. So therefore case 1 is over. Case 2 is another case, student. Tell me, if delta O, the octahedral splitting energy is less than pairing energy, students, then what will happen?
The electron, there will be no pairing and the electron will go to Eg. So the electronic configuration will be T2G3 Eg1.
T2G3
Eg1.
EG1, students. That is a correct answer, student. Now tell me, this means the ligand will be what type of ligands here?
A weak field ligand.
Weak field ligand, correct answer. Correct answer given by Shivangi. You are a very brilliant student. Only thing is you have not been coached properly. So my purpose is to give you a coaching student so that your practice becomes very high and you will be able to solve question in fraction of seconds in the paper. So T2 G3 EG. Now is it a high spin complex or a low spin complex? Students fast.
This will be high spin complex.
Why it is high spin? Because on what basis you decide the high spin or low spin, students? It is based on number of.
Number of unpaired electrons.
Okay, that's my point. Everything, every word we have to think and think. So that our mind is become strong, because the paper, if you go for any competition, that will be a tricky paper. That will involve a lot of thinking. Student, it will be 20% higher than the NCRT stuff. Let me tell you very clearly. So those who cannot think, who cannot dive deep, they are out of the papers. It's not the question what is happening or what will happen. The question is my clear instructions to all students: you prepare your best. Students, don't worry about what is happening, corona or anything that we can't stop. And don't believe that there will be paper or late paper or no paper. That is not our problem. Our problem is our preparation should be very strong. So you prepare yourself the best. So students, this is what I said is a crystal field splitting. The crux of this, the heart of this has been discussed. And as you can see, why did I do all this? There is a diagram which is given in the NCRT book, from which I have taken this picture from a book, student. As you can see, the 5d orbital raised in energy, and then this is called barycenter 0 point, student. This is a stabilization energy which is minus 2 by 5 delta 0, student. That comes to be point 4 delta O, and this is minus and this is called plus zero point 0.6
Plus point
O
0.6 delta O.
delta O, octahedral splitting energy. The sum of the two, students, will be equal to 0, which is
0.
called the Barry center, as
Bary
given
center.
in the book, students. So if I multiply it, there are 2 into 0.60 and 3 into minus 1.2 plus, and that will come to the this point. Oh, that means the total energy is conserved. If something has got lower energy, the equal amount energy is raised to students. So the total energy remains the same, students. The conservation of law holds true everywhere in this world. So there is some physics, some science involved in everything if we start thinking. If we don't think blind, what we will do? The diagram is in the book, so you can see it, but students don't know what is the meaning of this. So we have to explain to you everything, the ligands, the power of the ligand, the field of the ligand, the spectrochemical series. And on this basis, students, for octahedral complex, the picture is absolutely clear. Is there any doubt now in this crystal field theory, or any questions are coming, students? Will you have any difficulty?
No, sir.
Okay, thank you very much that you are with me, students. So we have explained to you there is a crystal field splitting energy, student, which I talk of del or 0 for octahedral complex, or 10 dq. So the overall energy is maintained. Therefore, there are 3 T2G which are of lower energy, minus 0.40, and the others are going up, students. And as you can see, we have given you example of titanium 3 plus. Titanium 3 plus, student, has a 1 electron in the T2G. When I talk of Ti, student, what happens is, if I take titanium chloride and put in water, student, what will happen? The water molecules will displace the X minus ions. It
Okay.
is important that even when Werner has given his theory, the neutral molecules, he said, are the first preference by the metal ion. When the
Yes, sir.
neutral ions become less, then the metal ion starts getting the halide ions or other negatively charged ions. So what happens if I take titanium chloride, student, and put in water? What will be the result? It will form TiH2O6 3 plus ion in the water. So now
Okay.
this is a
Okay.
complex ion, student. It is a complex ion. And what has
Yes, sir.
happened here? There are 6 water molecules which are coming to the central titanium. And you are aware that 6 coordination number, it is octahedral complex, students. So they are
Yes, sir.
approaching from X, Y, and Z axis of an octahedral, and therefore the splitting will take place. And the result of that is, students, the one electron is going in the T2G. So what is the Ti3 plus? How many? What is the D count? What is the D count of Ti3 plus? Students, fast.
D1.
D1. I already said to you one thing that the series of scandium to zinc should be known to you. Scandium 21 to zinc 30. That series we learned it so well, student. Is it clear what we said? Scandium, titanium. Further complete it. Scandium, titanium,
Scandium, titanium, vanadium,
chromium,
chromium, manganese, iron,
cobalt,
cobalt, nickel,
nickel,
copper, and zinc.
zinc. Are you with me, students? 21, 22, and finally
Till
30.
30.
So five orbitals are there in D total 2 into 5, 10 electrons. Yes or no?
Yes, sir.
So students, every time we do
3D10.
repeatedly, it helps us. We get into the game. Student practice makes a man perfect. The best players, the best people who are making goals in the soccer match are those who have tremendous practice. Got it? Life
Yes,
is
sir.
like that, student. The more you work, the higher you go. The lesser you work, the lower you go. You have a choice. Every time we have a choice, student, choice is there. There is a choice point. Either you add and go up or you subtract yourself and go down. Choice is there, yes or no.
Yes, sir.
Those who will waste the time, they are sinking. Those who are adding the time, adding value to the time, they are going up. And let me tell you, the coaching helps you a lot, students, because that is where you can do something big in life. And don't think your money goes ever waste. No. Money goes waste when you use it for wrong things, students. If you are putting your money on the right things, it is good for you. It will benefit you any point, anywhere in your life. People will destroy you completely at some stage. Still, you will survive. Because your knowledge, nobody can take it from you. I can take a job of a person, I can hit a person, I can take his degrees zero, but I cannot take the knowledge of a person. Student, that is a set, permanent set. Yes or no?
Yes, sir.
So that is the story. Life is like that. So students, scandium, and this is the story. Then how if I write the configuration, student 2-1 means what? What we said 2-1 means 3D1 4s2. Got it?
Yes, sir.
So we have learned certain tricks, students, to write the electronic configuration. Also, as soon as we write the atomic number, okay. How did I do it? I learned it with my students. My students taught me. Don't think I am teaching you. I can't take all the students. I take students who can teach me also. You are also our teacher, students. I am only a coach and getting more and more learned from my students. I learn more from my students than anybody else. I thank you all for this. Student D1 count means so students, if I put a very strong field ligand, what will happen? The delta O gap will be large. Now, here is only one electron, so there is no dispute. It has to go to the
T2G.
rules which we use for filling, the rules for filling the electrons in this T2G and EG orbitals are, what are the rules on the basis of which filling is done? Students, tell me fast, 30 seconds. What rules you are using? In earlier, what rules you used for writing the electronic configuration of the elements?
Sir, first the electron would go to the s
Name the
orbital
principles.
of Bohr principle.
Second,
Uh, then Pauli exclusion principle.
next,
Um,
Hund's rule
Hunt's rule, yes.
of maximum multiplicity. Students, the same rules will apply. Then what is the problem? Why did I talk with you all these things? I have to get the knowledge from you people. You know it that it is just buried deep inside you, and you have to come out. So same rule, lower energy is always filled first, student. This is the law of science. Everything wants to have the lowest energy, and the lowest energy will come when you go to the lower. As you climb a building, student, what is happening? The energy is increasing. So the lowest level will be filled first, and then first they are occupying singly students,
Yes, sir.
and then pairing starts.
Pairing starts.
Pairing starts. So Hunt's rule, first they are singly, then pairing starts. So same rules we are applying up to D3. There is no issue. They all have to go to the T2, G3. After D4, 5, 6, 7, 8, the story changes because there are two choices. Those two cases we discussed, case 1, case 2. Students, if delta, because strong field ligands are there, strong field ligands are there, student, and you know which are the, or if there is a CO, this is a strong field ligand, what will happen? If I have D4 count, then what will happen? It is a pairing, or if it is a weak field ligand here, you student, then the next goes to the higher ones, because there are only two things where question will be asked: delta O and pairing energy. Pairing energy, students. So students, this much is clear to all of us. All of us. We have gone beyond NCRT book a lot, students. For your information, this is not available there. So the configuration D4 to D8 are possibility arise where there can be high spin or low spin complexity, delta E larger than pairing energy for electron. Then what happens, students? The electron pair up as far as possible. If energy of pairing of the electron is greater than delta O, electron will be distributed to T2G E0. That you case 1, case 2 you have studied, student. So
Yes, sir.
for example, in the case of, you can see, this is our D7. If I have D7 count, student, if there is a central metal ion, student, and there are 7 electrons in the d orbital, student, supposing student, if I have a field high field ligand, student, high field ligand, then what will happen, students? High field ligand, for example, CO or CN, these are very high field ligand, some of the example, and nitrogen, you are saying easily diamine, etc. High field ligand, then what happens, students? You are saying, sir, this is the story. Now this gap, what is this called? Crystal field splitting
Crystal field
energy,
splitting energy.
octahedral complex. So what happens first? One, two, three of Bohr principle. After pairing has takes place only
Pairing
after
has
that.
to start.
So Hunt's rule for, because this gap is delta O0 is large than P, students. How many are there now? 6. And next then goes to this. Okay? So
Yes, sir.
the low spin complex, student. How many unpaired electrons? One unpaired electron.
One
One
unpaired electron.
electron. Unpaired. Students. Okay. Now if I have a low field ligand, weak ligand, student, low field, weak field ligand. What are the examples of that, student? Fast, 30 seconds. Cl minus, Br minus.
Cl minus, Br minus,
I mean,
Hcl minus, I minus.
halogens all are on the lowest side. It has been given. What happens now, student? 1, 2, 3. Okay? And you are saying now the this energy gap is less, student. Delta O T2G EG. If I do a mistake, you will tell me. 1, 2, 3, 4, 5, 6, 7. Am I right or wrong?
Yes, sir.
Delta O is less than pairing energy. Therefore, student, what has happened here? How many unpaired electrons?
Here, 3 unpaired electrons.
3 unpaired electrons. So this is a high or low spin complex.
This will be high spin complex.
Okay. If we want to calculate the crystal field splitting energy, that can be calculated by the formula I told you, student. Crystal field splitting energy can be calculated, or the stabilization energy, crystal field stabilization energy can be calculated, students. crystal field stabilization energy can be calculated, students. What is the formula, student? You have minus 0.40 delta O into number of electrons, ठीक है,
Yes.
Ne number of electrons plus 0.60 delta O into number of electrons. These are the number of electrons in which one? T2G.
T2G.
Number of electrons in EG.
EG.
By this formula, we can calculate the crystal field stabilization energy, student. In certain competition, that question has been given. So this is the way we calculate crystal field stabilization energy. The more negative means more stabilization energy, student, lowering of the energy, and more higher means more repulsion is there. Then you can see the spectrochemical series in more detail given by another book. I mean COC, and that's bipyramidal E, and nitrogen compounds on the higher side, student, and then the halogens are on the last side. See, these halogens are falling back.
Yes.
One of the limitation of the crystal field theory is we could not explain this reason. We will see that. There is, don't think this is the end of the theory. There is another theory which is not in our course. So we are not going to discuss that. Beyond that, that is molecular orbital crystal field theory. Because the problems will come here also. Every time there are certain assumptions and certain things unexplained, students. The ligands are more negatively charged. They should have a stronger field. But here you can see they have a weaker field. We put in the last series of the last of that. Got it? Neutral
Yes.
molecules have no negative charge. Still, they are causing more splitting. And it also depends on the metal ion, students. In general, the larger the charge on the cation, the more will be the interaction. Because what is happening, there is a positive charge which is attracting the negatively charged ligand. The more the positive charge on the more the positive charge on the student central metal ion, so it should lead to more splitting, yes or no?
Yes, sir.
So here this is not going to be asked, but here I have tried to give you that also point. You see, pt4 plus is will cause larger splitting as compared to 3 plus ions. 3 plus ions, 2 plus ions are on the end. 4 plus ion, then 3 plus ion, then 2 plus ion. These are all experimental data, students. We have to take it from some experimental book source. So many things you see. I told you, okay, this in amines, I told you a question is coming all the time, the basicity of the amines, and we said methylamines and triethylamines. When we do
Yes, sir.
water, that question will come in the paper. Now, when there are more than one factors, then we say, okay, the it is complicated, but at least the information given in the book we have to remember. Got it? So
Okay,
these are
sir.
some of the things which we have discussed, student. Thank you very much for interacting with me. Now the story is, students, the we have told you all the rules for filling up the electrons in T2G, EG. You told me of principle, hand rule, Polysaxel principle. I thank you for that, students. And you can see that one of the most important thing is how to why these coordination compounds are colored, student. Why coordination compounds are colored? How can we explain the color, student? And then ligand field theory, crystal field theory offers an explanation, student. Offers an explanation for color of the metal ions, students, in these coordination compounds. In these coordination,
Compounds.
okay, students, you are not sleeping, have a nut. Now the story is what happens is that because of the splitting of the d orbital, students, there are electrons in the T2G. They can absorb, student, they can absorb light, and then they will get excited to a higher energy state. Okay? They will absorb
Okay.
a definite wavelength of light. If it is a visible, there are 7 wavelengths of light, 7 frequencies. So out of that, they are going to absorb one of the wavelength, depending on the delta O value. ठीक है, depending on how much different ligands are making, delta O is different for different ligands. So different wavelengths of lights will be absorbed, and the complementary colors is what you see, students. And you know very well, it is told so many times that once the electrons are excited, they will not stay there. Once they come back to the lower state, student, what is happening? They will emit radiations. So student, here for example, the complex which I told you, TiH2O6, student, 3 plus. What is the IUPAC
Okay.
name of these students? What is the IUPAC name of this complex?
This will be hexa aqua titanium hexa aqua titanium 3.
Thank you very much. If I do a mistake, you will tell me. Did I write the correct name?
Yes, sir.
Okay, then our hard work has not been wasted. You have been learning the how to give the high UPSC name. One question will be there. In the paper, give a high UPSC name. I mean, in paper, there will maybe 4 choices, which is the right answer. Okay, they will may do anyway. So students, question answers are familiar. We keep on asking question. We keep on doing question answers in our lessons to make the subject more clear. Now, in this, the D count is a D1, student.
Yes, sir.
And you have told me this is T2G1, EG0. So what happens, student? It absorbs a wavelength of light, and experimentally here, what is the wavelength or the energy required? That is about 2030 centimeter inverse, or in nanometers 493 to 520 nanometer. And if you calculate in kilojoules also, you can do it. 81 kilojoule per mole is 83.7 centimeter inverse, and this involves 243 kilojoule per mole of energy. As there is an absorption spectra also in experimentally they take it. You see that this is the 520 nanometer around where this is absorbed, and you will see in the spectrum violet to indigo, blue, yellow. What is that? 400 to 700 nanometer range is there. So the visible part, you can see that how the electrons are excited, and the light energy in the visible part, a wavelength or frequency is absorbed.
Okay.
Is a information given by spectrochemical analysis. What we see?
Okay.
Spectrochemical experiments have provided this information, students. Just to make the things more clear, I provided this to you. So this makes things more clear to you what is really happening. Okay, got it?
Yes,
This is
sir.
the case of titanium, students. So students, we have clearly indicated there are 2 types of complexes. Okay? One is a high
Yes,
spin
sir.
and other is a low complex. Now the octahedral game is very clear to you, that where the electrons will be placed in the 2G or EG depending on the strength of the ligand. Question we will do later. Let us go further ahead. So in other words, again I have shown you octahedral splitting. This is our octahedral splitting. As I said, minus point 4, which is equal to minus 2.5 delta O, and what was this? Plus 3.5 delta O, or plus 0.60 delta O. This is our base center, 0 point.
Yes, sir.
Base center, student. What they have written is
Barry Center.
Barry center. What is the spelling if I wrong or right? Bary. Barry. Sometimes I do mistake, students. Okay. ठीक है? That is a NCRT also has given that. And in DQ they write minus 4 DQ. Total is 10 DQ. Deci. Q as a energy representation, quantum mechanical from the wave equation. So we will be using less of DQ students, more. Now the question is color in the coordination compounds. You have answered the question, student, why the colors of the coordination compounds is coming. What is your answer? 30 seconds.
So the color in the coordination compounds is due to the electron transition in the visible region of a spectrum.
What is the main transition takes place in which, what type of transition is that called? That is called DD
DD transition.
transition. Your answer is correct. You have to mention, student, this is what we are talking. T2G2 EG. What is happening? T2G2 EG.
EG.
Electrons are excited from T2G2 EG. That falls in the visible part of the spectrum. There are 7 wavelengths. Which of the 7 will be absorbed? According to that, there will be color of the complex.
Coordination compound.
Okay. One question is asked on that, student, so we have to be clear. So here we are helping you a lot, student. This is a picture to show that what type of colors are being observed, students, in the coordination compounds, and what is the wavelength of light absorbed in nanometer has been given. Data is available in books. So what we are saying, transition metal atom or ions with one or more unpaired electrons and their complexes exhibit color both in their solid and. Now remember one thing, student, the trick is, as I said, student, in earlier also, where I said in transition elements, I told you that color of the transition elements is due to DD transition. I told you when
Yes,
we
sir.
learned transition elements, and I said the catch is those which have unpaired electrons. Those which have unpaired electron, students, they will show color. If there are no unpaired electrons, there will be no color. Simple thing in the exam. Because if there are unpaired electrons, they can be excited from lower to higher energy. If the electrons are paired, then there is a more energy is required, and it is not possible in the visible region. So what we are looking is a visible part of the region. Got my point?
Yes, sir.
They may be absorbing light in some other regions. Other regions, ultraviolet or IR, other regions are there. But can you see those regions?
No, sir.
Okay. And then you have to use spectroscopic methods to study that. So therefore, our things become more clear. If there will be unpaired electrons in the metal ion, they will show color, students. That will be, if everything is completely filled or paired, what will happen then? So there is no color. So students, they will show color in solid as well as in solution state. So transition metal ions or atoms, they show color in solid as well as solution
Solution.
states due to DD transition. In the exam, this is the important word. You have to mention DD transition. In lanthanides and actinoids, I told you FF transition. Did I tell you?
Yes, sir.
And the where you can see what type of transitions take place according to that. We have given some differences between lanthanides and actinides also. 4F was there, 5F was there. All the differences are coming. That question is coming in the paper many times. So
Okay.
students, for example, COCl, I am saying COClNH3 5 student 2 plus. Tell me, is it colored or colorless? Is it colored or colorless?
COCl.
Question. First, you find the D count of the cobalt. How
D
many?
count of the cobalt. Okay.
Uh, find the D count of the cobalt, students.
Plus 3 will be the oxidation state.
Cobalt
So
is in
cobalt will
oxidation
be
state here, student. If it is X, so it is -1.
plus 3.
Plus 0 is equal to plus 2.
Plus 2.
X
So
is equal
plus
to
3.
plus 3. Therefore, everything we did will be used. If we don't do that properly, then we are not able to do question further. So we have to, okay. X is plus 3 oxidation state, cobalt
Yes, sir.
3 plus. What is the D count?
D count is 3d6.
3d6 students.
Yes, sir.
Okay, there is a 3d6 here. And students, what is the nature of the ligands? You can see here. Cl is coming from one, ammonia are coming from the other side. So if I have a student T2G, what is the story? T2G, 1, 2, 3, the 4, 5, 6. ठीक है?
Yes, sir.
What will happen if the electron is excited from lower to higher energy? They will absorb what light they are absorbing. It is mentioned here. How much is that?
Yellow,
Wavelength of light absorbed is 535
535.
nanometer. Color of light absorbed is yellow. Yellow is 535 nanometer. And the color of coordination entity is violet. What they call as a complementary color of the light absorbed. So light absorbed complementary color. The complementary colors are given. The relationship between absorbed and transmitted wavelengths can be readily understood from the following. So this compound is colored here, and this is, you can see, cobalt. This one, 5, it is absorbing 500 nanometers. So as the ligands are changing, student, different wavelengths are being absorbed. This CN, the wavelength absorbed is how much? Cobalt, hexa, this hexacyanido, 310. Color of light absorbed, ultraviolet, and color of coordination. This is not in the visible, you are getting pale yellow. And in this case, red, and the complementary color of this red is blue. Titanium, this is 498. Blue green, what you see is the, what is this color, students? Violet. So crystal attributes the color of the coordination compound to DD transition of the electron. According to crystal field theory, the color is due to DD transition. Clear?
Yes, sir.
All right. Okay. Further interesting thing comes, students. That what happens, student? You have seen, for example, copper sulfate 5H2O question. You know what is the color of this?
Blue,
This is also called blue vitriol.
blue vitriol.
Okay. What happens, student? This is heated and it becomes colorless. Now you have to explain it. Question in the paper. You can see how the questions are prepared, students. What is happening, students? What is happening here? On heating, students, what happens to this? On heating, it loses water molecule.
Yes, sir.
Water is lost. What is left is copper sulfate. And what is happening? Where are the ligands now? There are no ligands.
Okay.
ठीक है? So what happens, student, when the ligands are absent, students, in copper sulfate, but in CuSO4 5H2O, you are saying CuH2O5 and SO4. Ligands present.
Yes, sir.
If ligands present, what will happen? Splitting of d orbitals will take place.
Yes, sir.
And what is the count of what is the d count of this copper?
Copper X plus 0 minus D count of copper is 3D9.
Copper 2 plus is,
Copper 2 plus 3D9.
so it, what will happen then? The electrons will be excitation of electron will take place.
Yes, sir.
The result of that will be what? That this will be colored, student.
Colored.
So copper 2 salts are colored, and when you remove this colored because of the splitting of the d orbitals. If the splitting of d orbital is not taking place, then what happened? The
There
same
will be no
process
color.
on heating lost water molecules, and then it became colorless. So students, this thing becomes clear to us now. CuSO4 5H2O is the one which is colored, student, which is blue in color. Therefore, the CuSO4 and hydrous, this is colorless. Interesting. We never knew about it. We only know copper sulfate is blue in color. Question answered. Such questions are important, student, for us.
Yes,
Similarly,
sir.
for example, student, TiH2O6 questions can be asked. Such questions will be asked in the paper. TiH2O6 Cl3, students. What happens? This is colored. What color we have seen? Titanium 3 plus. Titanium 3 plus in water. What was the color of that? We have just shown you some color of titanium. Where is that titanium H2 plus? Violet. So this is having
Violet.
violet color. Violet color. On heating, on heating, student, what happens? It becomes colorless. So what is your answer, students?
Sir, when this complex is heated, it will lose all the water molecules and it will become anhydrous. As a result, it will lose all the ligands, and so splitting of d orbitals will not take place. DD transition will not take place, and hence there will be no color.
That is the correct answer. All right. Then such questions will be there in the paper, students. So therefore, student, one more interesting thing is coming before us. देखो, if there is a complex, the color is due to the ligands. If I keep on changing the ligands inside the metal ion, what will happen? Will the color be same or different? Will the color be same or different, students? If I
Sir,
change the ligands, then what will happen, students?
sir, color will be different.
Color will be different because these d orbitals splitting is taking place. They are under the influence of ligands. For one of the example which became a question in one of the paper, this is my, what is the name of this compound? What is the name of this compound? Hexa aqua nickel.
Which one, sir? This one. Okay.
Uh,
Hexa aqua nickel.
nickel 2
Nickel 2.
2. This is green in color, students.
Okay.
Add one en and the complex becomes this. See, two water molecules out because En is a bidentate ligand. This
Yes,
is
sir.
green in color. Green in color. Now what is happening to the color, students?
Pale blue.
Okay. Now it is becoming, students. This was green in color, student. Green in color. Now it is becoming pale blue. Color changed.
Yes, sir.
Further added another En molecule, more of En, more of N. In the ratio, we are reacting them. We are reacting this bi-rendered ethane 1,2-diamine progressively is added in the nickel complexes in the ratio of 1:1, 2:1, 3:1, and the series of reactions we have shown. So this is 1:1 student, and now we are putting En is, this is 2, this is 1. Then what is happening? There are 2 En now. ठीक है? The
Yes,
color
sir.
is changing from this one pale blue to purple color. Color changes takes place. You add another En student. This is 3, this is 1. Then what happens? 3:1. Then it is becoming violet in color. So as the series of reaction shows students what is happening here, what is happening students. In aqueous solution of complexes of nickel 2 with an increasing number of ethane 1,2-diamine ligands, the color is changing. Is it changing?
Okay. Yes, sir.
Question. In aqueous solutions of nickel 2 complexes, nickel 2 complexes student with with increasing number of En ligands color changes. Explain. So what is your answer, student? You have got 1 minute to think. Don't answer fast, student. Always say you take your time. You are complete going for 100 of the 100 marks, so you should know what you are talking about. What is the answer, students? Time is running out, students. You already know we have given you so much information. What should be the story? What should be the doubt, student, to you? What will happen? Why the color will keep on changing?
Due to the change in the number of ligands.
Then what will they do? That is our point. We are already saying we are changing the ligands. Did I not say that I am adding progressively increasing number of En? That I am already giving you the fact that ligands are changed. Then ligands are changed. Why will the color change? That is my question now. What happens when the ligands are changed fast? You are reaching near to the answer. When the ligands are changed, student, what will happen? If I change the ligands, what will happen? What will change? Delta O0?
Okay.
Splitting
Delta
energy will change.
splitting energy will change. Okay.
And as this value will change, student, what will happen? The wavelength of light absorbed will change,
Change.
and therefore the color will change. You got the answer that how what was required for the question answer. They wanted to see that you are aware of this splitting energy, students. Clear?
Yes, sir.
Okay. Question answer will always be one word or one answer, or objective type answer is either yes or no, nothing more than that. But can you answer any question without thinking? No. Those who have not understood anything, what answer they will give you? They are guessing only. Objective type question. What you are doing there? Okay, students?
Yes, sir.
All right. Okay. One more information before I close my session, students. Before I close my session, student. You have seen gemstone, students?
Yes, sir.
Gemstones. You have heard about ruby stone? You know, a lot of people use it for astrological things. That they put it that it is good for their luck. These are very colored, students. They have colors. What is the reason of the color of these gemstones? Why gemstones are colored, student? Why gemstones are colored? What is the reason for the color of this? For example, ruby you have seen, because students, they contain chromium 3 plus ion. Ruby contains chromium 3 plus ion, student. 3
Okay.
plus ion, this is a transition metal ion. They contain transition metal ions, which is a D3. D3. They are distributed in them randomly, and chromium 3 species as octahedral chromium 3 are incorporated into alumina lattice. So what will happen, student? Because of the presence of the transition metal ions, there is a aluminum oxide in that is present some 0.5 to 0.52 student 1% of these chromium 3 ions. So transition metal ions will be responsible for the color because they, as you can see, D count D3, there will be DD transition, students,
Yes, sir.
and that's why they have beautiful colors.
Okay.
And those colors are being used by people where they are wearing in their hands and at their whatever ornaments they are making. They are using those ruby stones, gemstones for improving their luck. Actually, it is the transition metal ion which is giving that beautiful color. And you know about it. It is a DD transition which is taking place. So I hope the session is clear, students. Everything is absolutely clear. The color of the transition elements and crystal field theory for octahedral complex is absolutely clear to us.
Yes, sir.
Any doubt is left to you, students?
No, sir.
Okay, then good night. We end up the session with you. Thank you very much for being with us, and we will meet you in the next class.
Okay, sir.
So many questions have been answered. Interesting session. Okay.
Okay. Thank you, sir.
Please keep on sharing our videos with your friends. It requires a lot of hard work, which we are doing for our students.
Yes,
So
sir.
help us in a way that it goes to more and more students. They can subscribe our channel and get plenty of information for the coming exams. And you can recommend
Yes, sir.
our name to few of your friends. Okay. Thank you very much.
Yes, sir. Okay. Thank you, sir.
We will meet you in the next class.
Yes, sir. Thank you, sir.
Okay.